Welcome to Precalculus Algebra, Composition of Functions Part 2. So we're going to gain some more practice finding the composition of functions, but in this video we're going to stress finding the domain of the composition. And one thing to remember is that you want to always find the domain before simplifying. So you find the composition, and before simplifying, if there's simplifying to be done, you want to find the domain. Okay, let's get some practice on this. So for the function f of x equals 1 over x, and g of x equals the square root of x minus 1, we want to find four functions: f composed with g, g composed with f composed with f, and g composed with g, and their domains, okay? So we're going to start off with f composed of g. Now f composed with g, by definition, that's equal to, so the rule for this function is, by definition, f of g of x, as you remember from part 1. And the way we handle this is we replace g of x with what it's equal to. So g of x is the square root of x minus 1. So this is f of the square root of x minus 1. And then the way that works is you want to substitute for x the square root of x minus 1 in f, right? So you see x in f, and you want to replace it with the square root of x minus 1. That is whatever's in parentheses. So I see an x right here, and so I get 1 over the square root of x minus 1. Okay? Now that would be our composition, 1 over the square root of x minus 1. Now, for this to be defined, two things have to happen. First of all, we require that what's under the radical be greater than or equal to 0, right? You can't take the square root of a negative and get a real number. So we first write down that restriction, that x minus 1 under the radical has to be greater than or equal to 0. So let's write that down. X minus 1 has got to be greater than or equal to 0, which means that x has got to be greater than or equal to 1. That's the first restriction. The second restriction comes about from noticing that the square root of x minus 1 is actually in the denominator of this fraction, right? So the denominator of a fraction can never be equal to 0. So in other words, we require that the square root of x minus 1, right, never be equal to 0, because that occurs in the denominator. So we're going to figure out when it is equal to 0 and then exclude that. So the square root of x minus 1 is equal to 0 when x is equal to 1. So that occurs when x is 1. So this is true for when x is 1, and therefore x cannot be equal to 1, right? Because when x is 1, this occurs. So we have two restrictions. We have, according to this, x has got to be greater than or equal to 1. That has to be satisfied. But this also says x cannot be equal to 1. So when you combine those two restrictions, right, x has got to be greater than or equal to 1, yet x cannot be equal to 1, you're left with the fact that x has to be strictly greater than 1. So the domain would be this, that x has to be strictly greater than 1, which means 1 to infinity. Okay? That would be our domain. So that's how you figure out the restriction on the domain of a composition. You ask yourself about all the restrictions that need apply. So that was the domain for f composed with g. What about g composed with f? Let's go ahead and find that function and then find its domain. So once again, f of x is 1 over x, g of x is the square root of x minus 1. So let's first find g composed with f, and by definition, that's equal to g of f of x. And the way this goes is you replace f of x with what it's equal to, which is 1 over x. So we have g of 1 over x. And then you replace the x in g, right? So x is right here. You replace it with what's inside the parentheses. So we have the square root of 1 over x minus 1. Okay, and that's our function, g composed with f. Now, where is it defined? Let's look at the restrictions. First of all, thinking about 1 over x, right? So 1 over x requires that x not be 0. That's the first condition, right? X cannot be 0 for that to be defined. But there's a second restriction. After that, you take the square root of this whole thing. So the square root of 1 over x minus 1, right? That requires that 1 over x minus 1, that is what's under the radical, be greater than or equal to 0. That's the second restriction. So we have to figure out when is that true. Well, this is an example of a rational inequality. So we have videos on that, a rational inequality. So you'll want to look up the video that I created called it's called Solving Quadratic and Rational Inequalities. And the way we do that is we get one single rational expression on the left, and it's going to be 1 take away x divided by x. We want that to be greater than or equal to 0. And now we create a number line with the numbers that cause each expression to be 0. So this is 0 when x is 1, and this is 0 when x is 0, and you put those on a number line. So 0 and 1. And then you look at the expression 1 minus x over x. And so we pick some test points. When x is less than 0, this is positive, this is negative, so the quotient will be negative. Between 0 and 1, positive and positive, so the quotient will be positive. And when x is greater than 1, pick a test point like 2. This will be negative divided by a positive, which is a negative. And so this quotient is greater than or equal to 0 between 0 and 1. So between 0 and 1 is when this is positive. Okay, so let me go ahead and just erase this for a second here. So I'm just going to write down that interval 0, 1. Now, I left off the endpoints for a moment because this quotient is equal to 0 when the numerator is 0, and that occurs when x is equal to 1, but it's undefined when x is 0, right? So we don't want to include that endpoint. So this would be the interval that satisfies that rational inequality. So now what we have to do is we have to combine the first restriction, that x can't be 0, together with their second restriction, that x has to lie in that interval. And when you combine those two, x cannot be 0, but x has to lie in this interval, you find that this interval is the solution, right? This already excludes 0, so we're already in business. So our domain is just going to be from 0 to 1. This is the set of numbers that combines both of those restrictions. Okay. Okay, what about for the third function, the third composition we're asked for? So we want to find f composed with f. So by definition, that's going to be f of x, just like before. So you replace f of x with what it's equal to, which is 1 over x. So we have f of 1 over x. And what does this say to do? Well, it says to replace x with 1 over x in f. So I put a 1 over x in the denominator there, and I get 1 over x. Okay, so before simplifying, we have to find the domain. So the domain, well, what has to be true? Well, first of all, x cannot be 0 in this denominator, right? So I can see that for 1 over x to be defined, what's got to be true is that x cannot be 0. And then, are there any other restrictions after that? Well, there aren't, because if x is not 0, this is defined, and then you'll have just 1 over some non-zero number, and that is defined. So once we have taken that restriction into consideration, then we can simplify this and actually write, well, 1 divided by 1 over x, that's 1 times the reciprocal, right? 1 times x, which is just equal to x. So we have f composed with f. The simplified version is equal to x. But it's important to write that the domain, right, has this restriction. X cannot be 0. So this is the function as long as x is not equal to 0. Okay, so once again, you find the domain before simplifying the function. Okay, finally, let's look at the last composition, and that's g composed with g. So by definition, that's going to be equal to g of x. So we replace g of x with what it's equal to. So we have g of the square root of x minus 1. And then this says, hey, where you see x in g, right here, you replace that with all of this, the square root of x minus 1. So this x is going to be replaced with the square root of x minus 1. So we're going to get the square root of the square root of x minus 1 minus 1. Okay, that's our composition. Now I see two restrictions here. First of all, this one, right? So for the square root of x minus 1, for that to be defined, we need what's under the radical to be greater than or equal to 0. That is x minus 1 to be greater than or equal to 0. It's got to be positive, or 0. So that x has got to be greater than or equal to 1. That's the first restriction. The second restriction says, hey, what about the big radical? Well, everything under it has to be greater than or equal to 0. So what we need now is that the square root of x minus 1 minus 1 has got to be greater than or equal to 0, because that's everything under the other radical. So for this restriction, that means that the square root of x minus 1 has got to be greater than or equal to 1. And because these are both positive, we square both sides and we get x minus 1 is greater than or equal to 1. That is, x is greater than or equal to 2. So we need both restrictions to be satisfied. X has got to be both greater than or equal to 1 and greater than or equal to 2. And when you take those both into consideration, that they both have to be satisfied, what has to be true? Well, the domain has got to be greater than or equal to 2. Right? Because they both have to be satisfied, and only numbers greater than or equal to 2 will satisfy both of those. So this is our domain, and this would be our function, right? So g composed with g of x, it can't be simplified any further, is the square root of x minus 1 take away 1. Okay, so finding the composition of functions is really important, and their domain is something we have to take into consideration as we work with functions now and in calculus. Okay, until next time.